Hi, this is Alex from devstories.eu. OpenCV Computer Vision Deep Dive, Episode 20 of 20. For decades, computer vision algorithms were entirely passive. They could draw a bounding box around a cup on a table, but that was the end of the line. Today, the system does not just see the cup, it uses that visual data to reach out and grab it. The bridge between seeing and doing is the vision-action loop, driven by Agentic AI. Before getting into the mechanics, we need to draw a hard line between two technologies that sound similar but do entirely different jobs. A standard vision language model, or VLM, is descriptive. You feed it a screenshot and it outputs text telling you what is on the screen. A vision-language-action model, or VLA, is executive. You give a VLA a screenshot and a goal, and it outputs executable commands. It does not just describe the user interface, it actively interacts with it. Agentic AI turns a vision pipeline into a sensory organ for a decision-making engine. This operates in a continuous cycle of perceive, reason, and act. First, the system takes a visual observation of its current environment. This could be a camera feed from a robot or a real-time capture of a computer desktop. Next, the agent processes this visual state alongside a specific prompt or goal. It analyzes the spatial relationships, reads text, and identifies interactive elements. When the model identifies an element, it maps the semantic understanding, knowing that a specific green rectangle is a submit button, to a geometric coordinate space. Finally, instead of returning a description, the model generates an action payload. This is often a structured command containing exact screen coordinates, a hardware motor adjustment, or an API call. Once the action is executed, the environment changes. The agent takes a new visual observation, checks if the previous action succeeded, and calculates the next step. Here is the key insight. The visual data is no longer a dead end. It is the grounding mechanism for autonomous tool use. Let us walk through a concrete scenario of an automated digital accounting assistant. The goal is to authorize a payment. The agent starts by capturing the screen. The vision model processes a scanned PDF invoice extracting the vendor name and the total amount. The reasoning engine knows it needs to log this data. It generates an action to move the mouse to the accounting software icon on the taskbar and click it. The screen updates. The agent takes another visual observation to verify the application is open. It scans the new interface, locates the payment authorization field, maps the visual location to screen coordinates, types in the amount, and clicks the submit button. The vision pipeline constantly feeds state updates back to the agent so it knows exactly when to execute the next action and, more importantly, when to stop. Computer vision has evolved from a standalone analysis tool into the sensory layer for autonomous systems. If your pipeline only analyzes an image and stops, you're only utilizing half of the technology. Since this is our final episode, I encourage you to explore the official documentation for VLA models, try building a basic feedback loop hands-on, or visit devstories.eu to suggest topics for our next series. That's all for this one. Thanks for listening, and keep building.